we've been talking about these logs and this activity is going to be logged there. Let's get into these logs themselves. Let's look at the status codes. I've talked a little bit about them, but we want to dig down deep. So remember, on Windows machines, the logging mechanism built into the operating system for web logs would not be the EVTs. It would be a separate log file for the web server. And if we built a custom application, we could either redirect all of that information about the logging mechanisms to our application log or to a separate log file. I've seen in very large, very robust enterprises where they do just that. They redirect all that information to a separate log file and don't trust this mechanism of the application EVT log there. For IIS, you've got the local logger, you've got the EVT. For Apache web servers, now you're usually, most of the time you run Apache on a Linux server, so you're looking at the syslogging mechanism. These logs that are sitting back here, are they encrypted? Are they protected? Are people from the outside denied access to these logs? If the answer is no, then you've got a serious problem. If the answer is yes, you've probably taken care of that by doing some sort of log shipping or log management where we've picked up the logs off this local machine and sent them on their merry way. So when we talk about log security, it's not only about creating and collecting the events here, but also lifting them up and sending them out there and making sure none of that stuff sits behind. And that's a mechanism of design. From a forensics analysis standpoint, we would look at those machines and we would see those two with all that information. All you would see as an output here would be a really long HTTP request and referral back and forth. So we have to protect those logs because they have the data in them, or they may have the data in them, especially for custom applications. Okay, so now we're talking about the HTTP logs only, the standard logs for both our Apache servers and for our IIS servers, and if you have Nginx servers or Google servers out there for web. These logs have a 3-digit code that logs the status of all transactions. These codes are important to you because they tell you what happened in the transmission back and forth. The first one by itself is 100, which is continue. We don't see the 100 that often, but we're looking for that 3-digit number in there, and that says, okay, keep on supplying this data. 200s, we see those all the times in the log files. That's successfully fulfilled a client's request. 300 is a redirect. Hey, I don't have that service here, it's over there. I've told the client where to go. I don't see the rest of the transaction. If I own that web server over there, I would see the establishment of another session, and I would see a 200 there. So I'd have to do log correlation to bring these two together. 400, client error. 500, server error. When you see 500 server errors, something's really broken on the server. And by the way, that gets issued back to the client, and they get a 500 error, and it says server error at that point. Usually, what they'll do with these status codes is they'll reprogram them in the server, and they'll make it a nice glossy message here so that it doesn't say something like 404, file not found, right? You've seen 404 at least once in your life. File not found, client error. You asked for a file that I didn't have, 404. What we do is we dress this up very nicely and say, we're sorry, you've searched for a file that doesn't exist on this server. Would you like some help? Here, click this button. Would you like to go to our search dialog box? Here, click this button. And we dress it up and put it really nice out there. You need to know your HTTP log status codes if you're ever going to do any kind of log analysis, forensics investigations of web servers themselves. What we're going to see in the log file besides that status code is going to be the time and date, the source IP address, where you came from, the HTTP source code, in other words, the URL that we went to, and the requested resource along with the status code. The IIS log is going to be sitting inside of System32 log files. Each server or each virtual server that's sitting on that machine will have its own subdirectory underneath of that, and it will be listed off and it will name the server in it. By default, all this logging is clear text ASCII, so it is editable, if you will. Now what we do is we parse these logs in a lot of cases for the Windows side of the house. You can actually pick these up. When I look at log files, I use a tool called UltraEdit because it doesn't have any restrictions on the file size, and usually the logs that I get are a couple hundred megabytes in size. Before you double click on that .txt file, figure out how big that is, because your normal notepad isn't going to be able to handle this data that's flowing back to it, and you certainly don't want to open it in Word. Find an editor that will do this for you. You could also, if you wanted to, you could grep that file and you could redirect it through and say, only show me the errors, or only show me between these two dates, as long as you know the file format. So that would be reasonable to redirect that and pipe that through and only take the results that you actually care about on this 50 or this 100 meg file, because it can get very large. Today, people are trying to manage those logs a little bit better, and they chop them off and they pull them out of those servers before they reach such large capacity. That shows good log management if you're pulling them off once a day, once an hour, once a week, depending on the volume of traffic over that web server. So parsing those logs, you can do that manually. You can do that through grepping. When we're looking at the Windows FTP log fields, because sometimes what we do is we stand up a Windows IIS server, along with it we issue files from it, it has a different log structure to it. It talks about the query, the host, the user agent, the cookie, the refer, and the substatus. These are all FTP from an IIS server. Basically, I'm from an IIS server that's running FTP as another protocol on it. So you would see that they would authenticate. Hopefully you're not doing anonymous FTP on your corporate sites. You may do that for file sharing on large software distribution sites, but not for most corporations. You'd see the data back and forth. That was pretty close to what it looks like in the web server, but here we're just doing file service. Let's talk about the credibility of IIS log files as forensics evidence. First rule, if there are any configurations when you're logging, any ability to add more information, log everything. The default log that you see on an IIS server leaves a couple of boxes unchecked. Go into that log server, go into that logging mechanism on that IIS server and choose to check those. Or if you're dealing with an enterprise, say, hey, will you please start logging everything in the IIS log, in the HTTP log, so that I can have access to that later on. That good logging up front, collecting all that information, will make for, well, just an easier time of forensics trying to figure out what happened. If they're using some sort of custom application with the standard in, standard out, ask them how often they're cleaning off those logs and where they're placing them, and are those logs protected when they're put in that other place. So you can do the extended logging on that server. You can configure the IIS information. Remember, from a logging standpoint, if we log and monitor on a continual basis, this is evidence, or respected as evidence in a court of law. So we need to up the credibility on that IIS log file. Next, what we're going to take a look at is all the different components of credibility for logs and the Apache servers themselves.